Alrighty, let's get started on this last section of Chapter 4. And we're going to be talking about polynomial and rational inequalities. And really, we're just doing the exact same thing we've been doing, but we're now looking at inequalities instead of equals. Okay? So the first thing we need to do is determine the x-intercepts, their multiplicity, and determine whether the function crosses or just touches your x-axis. We also need to determine the end behavior of the polynomial, sketch it, and then determine which intervals satisfy our inequality. So taking a look at this to begin with, here is my function. I want to know for what values of x is this function greater than 0. And when we say the value of the function, we're talking about the y values. So when is y greater than 0? So the first thing is I've got to graph this. So multiplicity, we look at the leading term, so that's x raised to the power of 2, and the leading term here, x to the power of 1. So x squared times x gives us x cubed. So that tells us our ends have to go in opposite directions from each other. Now, our leading coefficient is a 1 here and a 1 here. So 1 times 1 is positive. So the fact that we've got a positive leading coefficient and an odd exponent means my ends are going to do this. So my ending behavior as I go towards x being negative infinity is going to get smaller. And as I go towards positive infinity in x, the y value gets larger. We also need to look at our multiplicities here. Okay, so this first one, and actually before the multiplicities, let's look at what is the x-intercept associated with this. So if I take the inside of this, set it equal to 0, so we have x minus 2 equals 0, we get an x-intercept of x equals positive 2. This one gives us an x-intercept of x equals negative 1. And I don't expect you to write this out. I'm just doing it for your notes. So I know that I have two x-intercepts, and I want to know what kind of behavior happens here. So on this one, the multiplicity is 2. And remember, multiplicity is the exponent here. So because that is even, that means this is going to bounce. It does not cross here. At the x-intercept of negative 1, the multiplicity is positive 1. If we don't write the exponent, it's a 1. So that is odd, so it is going to cross right here. So we're starting to get the pieces here. So let's take a look and finish this off now. And what we've got to do next is create our little number line. And the things we want to put on here are the x-intercepts. So I've got negative 1 and positive 2. And notice I don't really care what's going on around them. So I want to now try a value smaller than negative 1. So any x value smaller than negative 1, I'm going to try negative 2. Why not, right? If I put a negative 2 in here, negative 2 minus 2 is negative 4 squared. That gives me a positive. And again, I don't really care what the value is. I just care if it's positive or negative. So if I put a negative 2 in, I get a positive here. Negative 2 plus 1 is negative 1. So this is a negative. Negative times a positive is negative. So my values right here, any x value smaller than negative 1 is going to give me a negative value. Now we're going to try something just to the right of negative 1. And I always like to try easy numbers, so I'm going to try 0, because it's the easiest thing to plug in. If I plug in a 0, 0 minus 2 is negative 2 squared is positive. Will this term ever be positive or ever be negative? No, because we're squaring it. And when we square any number, it's going to be positive. So I almost don't have to pay attention to this. If I put 0 in here, 0 plus 1 is 1. 1 is positive. So that's a positive value. And we'll do the same thing as we get close then to 2. Well, we don't actually have to. That's positive also. Now, just above 2, I'm going to try 3. And again, it doesn't matter what happens here because whatever I put in here, when I square it, becomes positive. So this term will always give me a positive value for any x's. If I put a 3 in here, 3 plus 1 is 4. 4 is positive. And there is my table of positive and negatives. Okay, so we've got that. And let's just come back here for a moment too. So I've got what's going on here. I know I've marked my x-intercepts. We know at 2 it's just going to bounce. So that makes sense. That's positive on both sides. It doesn't change signs. And at -1, it crosses. So it makes sense that it's negative on one side of -1 and positive on the other. That means it crossed here. But let's see if we can figure out what our y-intercept is. So to get the y-intercept, we put zeros in for x. So 0 minus 2 squared times 0 plus 1. And I actually have to see this because I want the value, not just if it's positive or negative. So I get -2 squared is 4 times 1. So 4, 0 positive 4 is my y-intercept. Okay, so let's go ahead and now we're going to sketch our function. We need to put in our x-intercept. So we've got -1, positive 2. And we know that from our end behavior check that towards negative infinity in x, the y is going towards negative infinity. So I'm going to draw that arrow in, and I'm going to draw in the arrow, further over, excuse me. So I know at -1, I'm going to cross. My y-intercept is at 4, 2, 3, 4. At 2, I'm going to bounce. So I'm going to just sketch this in. I'm going to come in here, up to 4, down to 2, and then back up. So that's kind of what my function looks like. But I haven't finished the problem. I am solving for what values of x give me a y value that is greater than 0. So basically, where above the function is it positive? And again, I don't want it equal to 0. I want it greater than 0. So starting at -1 to negative infinity, we've got negative y values. But starting just above -1, we get positive. So from -1 to positive 2, those are all positive y values. And notice I'm using a parentheses instead of a square bracket. I am not including the values of -1 and 2 because the y values there are exactly 0. They're not positive. But after 2, we go positive again. So I'm going to have from 2 to positive infinity. And again, these are the x values that give me a positive y. And we want to join those, so we will put a u for union. So this is the answer to this problem. For these, in this interval and in this interval, the y value is positive. So now let's take a look at the next problem. Okay, so let's look at the second polynomial now. And again, we're trying to solve for x values such that x to the fourth is greater than x. Well, to make it easy for ourselves, what we really want to do is have 0 on the right side. So I'm just going to subtract the x. So I have x to the fourth minus x is greater than 0. So for whatever x's make this true, they would solve this inequality also. Okay, so if first step, I know that it's to the fourth, and the leading coefficient is positive. So I know both ends are going to be going up. So that's great. I know my ending behavior. I now need to find my x-intercepts. So to find x-intercepts, I want to factor. So when I factor, I can factor an x out of both terms. So I get x cubed minus 1 is greater than 0. Okay, and this may not be as familiar, but this is the difference of two cubes. One is a perfect cube and x cubed is a perfect cube. So this can factor, and I'm going to keep that x out in front, but the difference of two cubes, you might remember an acronym SOAP. So we have x1, x squared, x, and 1. And this is just the first term, the cube root of this, the cube root of that, first term squared, first times the last, and then the last. And our signs here are the same, opposite, and always positive. That's what SOAP stands for. So I have 3 factors now. Now we set each factor greater than 0. Well, we set each factor equal to 0 to solve. So this one gives me an x-intercept of 0. This one gives me an x-intercept of 1. This is not solvable with real numbers. And the way I know that is that it's a cubic, or it's a quadratic, and we're adding something at the end, the constant. So it's been shifted above our x-axis. So there are no real roots there. So these are the only 2 x-intercepts. My multiplicity, so So the multiplicity of this term is 1, so that means it crosses. The multiplicity of this one is also 1, so it crosses. Now we're going to do our sine chart here. And again, the only things I need to put on here are my x-intercepts. So I have 1 at 0, and I have 1 at positive 1. And I'm going to plug in values smaller than this to this equation. I'm going to plug in values between 0 and 1, kind of a pain because we're going to have to deal with a fraction here. And we're going to plug in something greater than 1. So let's take a look here and see what's going on. We've got less than 0, so let's put a negative 1. If I put in a negative 1, and again, I'm just putting the sign down here. So negative 1 is just a negative. Negative 1 minus 1 is a negative. If I put a negative 1 in here, square is positive, positive. So that's positive 1 minus 1 plus 1. That's a positive. So minus times minus is positive times a positive. Overall, that's going to be a positive sign right there. I'm going to do the last one next because that's just easier. So let's just take a look. Let's plug in a 2. And again, I'm just putting the sign of the values. So if I put a 2 in, that's positive. 2 minus 1 is positive. 2 squared plus 2 plus 1, that's positive. So that's positive. Now I'm pretty sure, since I've said it crosses, I should end up with a negative in here, but let's check and make sure. So I'm going to put in 1/2. That's just 1/2 is positive. 1/2 minus 1 is going to be negative. 1/2 squared is positive, plus 1/2 plus 1/2, that's positive. So positive times a negative is negative, times a positive is negative. Okay, good, that did work out. That's just a good sanity check. And we're going to sketch. And again, this is a very rough sketch. I don't know what's going on after it crosses. So let's just do a very rough sketch here. There is 0. There's 1. And notice I don't need to look for the y-intercept because if it crosses at 0, we know that's a y-intercept. And the ending behavior was up. So we put that in. We put that in. So we come down here. We cross. And again, we don't know what's going on down here. Cross and go up. And there may be lots of wiggles in here. We don't know. But I'm looking for what x values give us positive y values. So everything smaller than x is 0. So that's negative infinity up to 0. And again, we don't include it because we don't have an equal sign. Joined with everything greater than 1. So 1 to positive infinity. So that is my answer to this polynomial. We're going to turn this over now and do some rational functions. Okay, looking at a rational. Same concept. You have to sketch it out. And sketching a rational takes a little bit more time. So first thing we want to do, find vertical asymptotes. So I've got to factor this. The numerator factors into x plus 2 times x minus 2. Denominator factors into x plus 3 and x minus 3. Okay, so we've got that. Vertical asymptotes come from the denominator from any factors that do not cancel. So vertical asymptotes. If I set that equal to 0, I get x equals negative 3. This one gives me x equals positive 3. So I have two vertical asymptotes. I want to determine the end behavior. Okay, so that means I've got to determine if there is a horizontal asymptote or an oblique. And then, so my degree in the top is squared, degree in the bottom is squared. Since they're the same, I divide by the leading coefficient. So I get y equals 1. Okay, so if I have this horizontal asymptote, I do not have an oblique to worry about. That's nice. And we need to, again, have our x-intercepts and y-intercepts. So let's find those. So to find an x-intercept, let me make sure this is on here. X-intercept, we set y equal to 0. That's just a reminder. So if I say y equals 0, I would multiply both sides by the denominator. So I end up with just the numerator. X squared minus 4 equals 0. And that we've already factored. So we know that we get these two intercepts here. X equals 2. X equals negative 2. And again, it just comes from these. I wrote them in the opposite order here, actually. This one would give me negative 2. This would give me positive 2. Y-intercepts, we set x equal to 0. So if I set x equal to 0, and I'm going to use the factored form, or the unfactored form to find y. So 0 squared minus 4 over 0 squared minus 9. I get negative 4 over negative 9, which is positive 4 over 9. So my y-intercept is at 4/9, and then I do have a horizontal asymptote of y equals 1. Okay, so now I'm going to make my sine chart to figure out what's the function doing around our asymptotes as well as our x-intercepts. So I'm going to put on negative 2. Oops, I probably should make that negative 3. Negative 2, 2, 3, and 0. Because I need my asymptotes and I need my x-intercepts. So it's important to check for around all of these things. So things smaller, x values smaller than negative 3. Let's try negative 4. If I put a negative 4 in here, it's going to become positive, and down here it becomes positive, right? Because anytime we square something, it becomes positive. And we still would have something, I guess I should check it. So negative 4 squared is 16 minus 4 is positive. 16 minus 9 is positive. So we get a positive right here. And again, we're just looking for the signs here. So now we're going to put in something between negative 3 and negative 2. And I'm going to actually put in for each one here so we can see. So negative 2.5 gives me a negative. Negative 2.5 minus 2 gives me a negative. Negative 2.5 plus 3 is a positive. Negative 2.5 minus 3 is a negative. So negative times negative is positive. Positive times negative is negative. So I've got a positive divided by a negative. That gives me a negative value. I'm going to put that positive down here so I can see it. So now we need to do between negative 2 and positive 2. I would say let's use 0. We already have done that, right? We did it over here. If x is 0, y is 4/9, which is positive. I'm not going to do that work again. Now let's look between 2 and positive 3. Again, I'm just putting each value in here. So I'm putting in 2.5. 2 plus 2 is positive. 2.5 minus 2 is still positive. 2 plus something is positive. And 2.5 minus 3 is negative. Positive on the top, negative on the bottom. Dividing those gives us a negative value. And something greater than 3, let's try 4. 4 plus 2 is positive. 4 minus 2 is positive. 4 plus 3 is positive. 4 minus 3 is positive. So all positives. Positive times positive is positive. Positive times positive is positive. And we divide and we get a positive. Okay, so that's a lot in that sine chart. But let's go ahead now and sketch this out. I'm going to do my best to make this nice and neat for you. So we want to put in all the different things that we have. We've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm going to draw in my asymptotes first. So those are at positive and negative 3. Okay, so that's x equals 3, x equals negative 3. I also have a vertical asymptote at y equals 1. Again, we put those in as dashed lines. Okay, so I've got that sketched out. I also want to put in my x-intercepts at positive and negative 2. So there we go. And now we have to figure out what's going on with our function. So remember, anything smaller than negative 3, we have positive values for our function. Well, I can't put it below the asymptote because as I get close to my vertical asymptote, it would have to turn down, and then that would give us a negative value. So my function here must be in this top left quadrant, or portion. And my ending behavior over here, we said, was also positive based on my sine chart. So again, it's got to be above that horizontal asymptote. So there we go. Now in here, we know that we have a y-intercept at 4/9. So let's put that in. And we said our function between negative 3 and negative 2 is negative. So that means it must be down here. Comes up, crosses, comes to 2. Because again, between negative 2 and positive 2, it's positive. and then it becomes negative, so it must come back down here. And that should just be a review, all of this, the graphing. But now to answer the question, when are my y values greater than or equal to 0? Well, over here they're greater than 0, and from here to here they're greater than or equal to 0, and over here. So if I want to write this out, and I'm going to use interval format. So this is from negative infinity. Oops, that does not look like infinity at all. Negative infinity up to x equals negative 3. Because again, it doesn't ever equal negative 3. The function does not exist where there's an asymptote. And again, starting at negative 2 to positive 2, all those are positive y values. And finally over here, 3 to positive infinity. Now be careful, from negative 2 to 2, we want it greater than or equal. So equal is okay, so we include that with the square brackets. And then we use that U to say joined. And there we go. There's your answer. I know it's a long problem. Let's do one more, and then you're going to be free to work on the homework. Okay, in the home stretch here. Okay, so here we've got a problem. And we want to see for what x values is this y value going to be greater than or equal to 3? Well, first thing we want to do is set it equal to 0. So I need to subtract the 3. So I have 4x plus 5 over x plus 2 minus 3. I want that greater than or equal to 0. Okay, well, I've got to do some algebra. So to combine these terms, I have got to multiply this by x plus 2 over x plus 2. So let's see, we've got negative 3 times x plus 2 over x plus 2 is greater than or equal to 0. Distribute this negative 3, so we're going to have 4x plus 5. And I'm going to go ahead and they'll all be over x plus 2 now. So negative 3 times x, negative 3 times 2. And now combine our like terms. 4x minus 3x gives us x. 5 minus 6 gives us a negative 1. Well, that looks much better. Hopefully you're feeling confident about this. I like when it ends up nice and simple. Okay, so let's find all those key things. X-intercept. X-intercept is when y is equal to 0. I would multiply both sides by x plus 2 to get rid of the denominator. So I really would have x minus 1 equals 0. So x equals 1 is an intercept. Y-intercept, we set x equal to 0. So negative 1 over 2 is just y equals negative 1/2. Okay, this is going well. Vertical asymptote. Vertical asymptote comes from the denominator for any factors that don't cancel. You set them equal to 0 and solve. So we get x equals negative 2 is a vertical asymptote. Horizontal asymptote, we compare the degrees. They're both 1, so we divide the leading coefficients. 1 divided by 1 gives me y equals 1. We do not have an oblique. So now we just create our sine chart. And we only have 2 things to put on here. We've got our x-intercept at 1, and we've got our vertical asymptote at negative 2. And notice I'm not putting anything else on here. So when x is smaller than negative 2, so negative 3, negative 3 minus 1 is negative. Negative 3 plus 2 is negative. Negative divided by a negative is positive. So in this region, x is smaller than negative 2, we've got positive values. Between negative 2 and 1, I'm going to put in 0, which we've already done right here. It gives you a negative on the top, positive on the bottom, which is negative. And finally, over here on the right, value is greater than 1. So let's put in 2. 2 minus 1 is positive. 2 plus 2 is positive. Positive divided by positive gives me a positive value. So now we're going to sketch that. And we want to keep in mind negative 2 is undefined. That is your vertical asymptote. Whereas at x equals 1, we've got a point, an x-intercept. Okay, so let's graph this guy. And we will be done then with this set of notes. So first thing I'm going to do is put in my vertical asymptote. Oh, that's not a vertical asymptote. Okay, let's do a different color. We're going to ignore, this was supposed to be an x-intercept at x equals 1. My vertical asymptote was at x equals 2, so ignore the blue. Okay, there's my vertical asymptote, x equals negative 2. horizontal asymptote is at y equals 1. Okay. Sorry about that. And now our sine chart. So x is smaller than -2. We have positive y values. Again, I can't be close to the vertical asymptote or be beneath it, because as I get close to the vertical one, I turn and go downwards. So the function itself, let's do a different color pen. Our function now is right here. When we come into this middle section, it is negative. Okay, so between -2 and 1, it's negative. So that means I'm down here, but at 1, I cross and become positive. So I've got to be down here. Oh, and my y-intercept was at -1/2. There we go. So I've got to go through there. Remember, this is not a vertical asymptote. That was my mistake here. So I cross here and I stay positive. So I've got to get close to that vertical asymptote. There we go. That is our function. And now to answer the question, for what x values do we have y positive? Well, y is positive over here. So that's maybe from -infinity up to -2, but not including -2, joined with, where else do we have it positive? So down here it's negative. At 1, it becomes 0, so it's not negative, and that's acceptable because I want it equal. So at 1, I want to include that to positive infinity. And that's your answer now to this problem. And sorry, again, my little mistaken vertical asymptote. Okay, good luck. Ask us if you have any questions. You've got this.